Identifying solutions to a linear equation in two variables. I've included two examples here that you will see. The first type actually has both the x and the y in equation form, and it also has a chart in ALEKS, and so it'll have several different ordered pairs, and it's going to have a column for yes and a column for no. So first, what we need to do is we need to find out if this point is a solution to this equation. Meaning, if we were to draw this line on a graph, does that point exist on that line? So to do so, we have to take our numbers and substitute it in. Remembering that the first number is x, so we're going to substitute that 0 in the place of x, plus 6 times negative 4. Remember, be careful with your negative signs as you're doing this. Okay, so 7 times 0, of course, is 0, plus 6 times 4 is negative 24. And we look, does negative 24 equal 23? Well, no, it doesn't. So, of course, you actually have to bubble it in, I think, in ALEKS. Okay, so now let's go to the next one. We've got 7. You're going to substitute that negative 1 in, plus 6 times 5 equals 23. 7 times negative 1 is negative 7, plus 30 equals 23. So we're going to take negative 7 plus 30. Well, that gets us 23. And does 23 equal 23? Well, yes. So we're going to bubble that in. Okay, our next one we've got is 7 times 2 plus 6 times 3 equals 23. So 7 times 2 is 14. Plus 6 times 3 is 18. And 14 plus 18 is 32. And clearly 32 does not equal 23. For those that are dyslexic, please note that they are different numbers. I'm dyslexic, so I kind of look at things backwards. And the next one, or the last one we have for this example is, 7 times 5 plus 6 times negative 2. So 7 times 5 is 35. Plus, I'm going to go ahead and put it in parentheses, because whether you put 35 minus 12 or you do 35 plus a negative 12, you're still going to be subtracting these, and that gives you 23 equals 23, and so this one does. So we'll mark yes. Okay, the key to this is making sure that you're paying close attention to the signs, okay, especially if they decide to put a negative here in the middle. Okay, so please note that as you're working on these. The other type of an example, this is an equation, and it is y equals 8. Okay, and I don't know why this seems to stump some people, but if you're looking at this, it says y has to equal 8. So we're going to look at this first ordered pair. The only thing that matters is the y. Okay, so this number here, is 4 equal to 8? No. We're going to the next point. Again, we're looking at the y. It's a horrible arrow. So, does our 8 equal 3? No. Okay, we're going to go to the next point. Oh, that's a better arrow. Negative 1. Is that the same as 8? No. And our last ordered pair, again, we're looking at the y. and it is 8. Does 8 equal 8? Yes. And so we would mark yes for this example.